Welcome back to the Data Analyst. Today we are diving into a powerful forecasting technique for time series data. Double Exponential Smoothing. If you're ready to take your prediction to the next level, you are in the right place. Let's get started. Double exponential smoothing is an extension of single exponential smoothing. While single exponential smoothing adjusts for level, double exponential smoothing accounts for both level and trends in the data. Here's the basic idea. We use two smoothing parameters, alpha for level and beta for trend. It's perfect for time series data with a consistent upward or downward trend. In previous video, we discussed about single exponential smoothing. I think you all can remember in there we use one parameter for single exponential smoothing, that is alpha. If you're someone new but you want to learn single exponential smoothing, then go and watch this video. These are the key equations for double exponential smoothing. Level equation LT equal alpha yt plus 1 minus alpha time LT minus 1 plus t minus 1. LT, the estimated level or baseline value of the series at time t. It represents the smooth value of the data adjusted for trend. Alpha, smoothing parameter for the level ranging from 0 to 1. Higher value of alpha give more weight to recent data. YT, actual observed value of the series at time t. LT minus 1, level from the previous time period t minus 1. T minus 1 trends from the previous time period t minus 1. 1 minus alpha, weight given to the combined effects of the previous level and trend. This equation combines the actual value at t with the forecasted value based on the prior level and trend to update the level for the current time period. Trend equation TT equal beta times LT minus 1 plus 1 minus beta times t minus 1. TT, the estimated trend at time t. It reflects the direction and magnitude of change in the series. Beta, smoothing parameter for the trend, ranging from 0 to 1. Higher value of beta give more weight to recent changes in the level. LT minus 1. The changes in level between the current period t and the previous period t minus 1. T minus 1. Trend from the previous time period t minus 1. 1 minus beta, weight given to the previous trend. This equation calculates the new trend based on the change in level and the previous trend, ensuring the model adapt to changing trend in the data. Forecast equation Ft plus m equal Lt plus m time Tt. Ft plus m, the forecasted value m period into the future from time t. Lt, the level at time t. Tt, the trend at time t. M, how many periods ahead we are predicting. This equation combines the current level and trends to project future values. The trend is multiplied by m to account for the cumulative effects of the trend over m periods. Level equation smooth the data and update the baseline value. Trend equation update the trend based on recent changes in the level. Forecast equation uses the updated level and trend to predict future values. Together, these equations ensure that both the current value and the trend are factored into forecasting process. This is the dataset for today's session. In here, we have month and the actual sales value. We will use alpha equals 0.6 and beta equals 0.4 to calculate the level, trends, and forecast. Let's see how to calculate level, trend, and forecast manually, and after that I will show you how to perform double exponential smoothing technique using Minitab. So to calculate manually this value, we need these three formulas. So first one is L1. So in here we don't have previous value, so we take L1 equal Y1. So L1 is 500. So T1 is different between the first two observation. So T1 equal Y2 minus Y1. So it's 520 minus 500 equal 20. So L2 equal alpha Y2 plus 1 minus alpha time L1 plus T1. So it's 0.6 multiply 520 plus 0.4 times 500 plus 20. So 312 plus 208 equal 520. So T2 equal beta times L2 minus L1 plus 1 minus beta times T1. So in here our beta value is 0.4. So 0.4 multiply 520 minus 500 plus 0.6 times 20. So 8 plus 12, 20. So our T2 value is 20. Let's calculate forecast value F1 plus 1 equal 500 plus 20 equal 520. L3 equal alpha y3 plus 1 minus alpha times L2 plus T2. So our alpha is 0.6. So 0.6 times 560 plus 0.4 times 520 plus 20 equal 336 plus 216 equal 552. So our L3 value is 552. T3 equal beta times L3 minus L2 plus 1 minus beta times T2. 0.4 times 552 minus 520 plus 0.6 times 20. So 12.8 plus 12 equal 24.8. So our T3 value is 24.8. Let's calculate forecast value F2 plus 1 equal L2 plus MT2. In here we forecast one value ahead, so our M is 1. So equal 520 plus 20 equal 540. Our forecast value for F2 plus 1 equal 540. L4 equal alpha y4 plus 1 minus alpha times L3 plus T3. So 0.6 times 600 plus 0.4 times 552 plus 24.8 equal 360 plus 230.72 equal 590.72. So L4 equal 590.72. T4 equal beta times L4 minus L3 plus 1 minus beta equal 1 minus beta times T3 equal 0.4 times 590.72 minus 552 plus 0.6 times 24.8. 38.72 plus 14.88 equal 53.6. Let's calculate forecast value F3 plus 1 equal L3 plus MT3. So M is 1 equal 552 plus 24.8 equal 576.8. So forecasting value for April is 576.8. I'm not going to show you all the steps to calculate T5, L5, T6 and L6. I'm just going to put the numbers here. So what you have to do is calculate those numbers, the forecasting value also, and check whether you got this value or not. Let's calculate the forecasting value for month July using Minitab. So this is our data set, month and actual value. And then go to Stat and click Time Series and click Double Exponential Smoothing. And our variable, put our variable into here, into variable box, and click specific weight because we have alpha equals 0.6 and beta equals 0.4. So for level, that is alpha, we have to put 0.6 here, and for trend, that is beta, our beta value is 0.4, and tick generate forecast. And number of forecast, we need one forecast ahead, so I will put 1. If you need more, just put the number here and click storage, and I click level estimation, trend estimation and forecast, then click OK, then click OK. So here's our value, here's our output results. So in here we got 734.43 as forecast value for month July. But when we calculate it manually, we got 724.89. So we have 10 gap here. So that is because in here, can you see in here, they automatically calculate L1 as 494.667 and they automatically calculate trend as 43.2. That's why we got different value for forecast value for month July, because when we calculate it manually, we use L1 equal Y1 equal 500 and T1 equal Y2 minus Y1 equal 520 minus 500 equal 20. That's why we got different results.